Good afternoon. Welcome to this webinar, Increase Your Geothermal Sales with GeoDesigner. This event is brought to you by the News. It's sponsored by Climate Master. And I'm your moderator, Mike Murphy, Editor-in-Chief of the News. Thanks for joining us today. Today's expert presenter is Richard Hiles. Mr. Hiles is the Mid-Central District Region Manager for Climate Master Incorporated. He is a 32-year veteran of the heating and air conditioning industry who completed an HVACR course at ITT Technical Institute in 1978. Mr. Hiles has 8.5 years with another geothermal heat pump manufacturer, is an IGSPA accredited installer and trainer, and has passed the Certified Geothermal Designer test through IGSPA and the Association of Energy Engineers, and has recently attended the Certified Energy Manager course through AEE. He provides technical and application training on geothermal energy systems for distributors, manufacturers reps, contractors, and other professionals in the HVAC industry. And now it's my pleasure to turn this over to Richard Hiles. It's all yours, Richard.
Thank you, Mike. Good afternoon, everyone. Glad to see you with us on today's webinar, how we use GeoDesigner to get our operating cost comparisons and successful for your sales future. Why are more people buying geothermal systems? Well, in our surveys and results that we get, the number one reason is lower operating cost as we compare to any other heating and cooling system that's available out there in the industry. For you to be successful, you'll need to be able to show your customers how much money they can actually save with a geothermal system, and the easy way to do that is with our GeoDesigner software program. The GeoDesigner software program will allow you to generate operating cost comparisons from various heating and cooling options for your customers, and it will also provide information for us for the loop requirements for you to have an overall successful installation of the system. This software program is free for you at our website, cmdealernet.com. This website was set up exclusively for the Climate Master dealers. There's a ton of useful information you can get on this website, sales literature, technical information, many useful things. Today we're going to focus on the Sales Tools tab. When you hit the Sales Tool tab, you'll bring up a screen and you can go down the left side and pick up several of our software programs. The GeoDesigner software program, our sales proposal program, and a pressure drop calculator to help you size the loop pumps and make sure we're getting a good overall design on the system. So once we click on that GeoDesigner link, you'll be able to download the program right to your hard drive. There is a process to go through. When you first receive the program, it'll be in a demo version. The demo version allows you to work with the GeoDesigner program. However, the weather city is fixed for Oklahoma City, Oklahoma, where we do all the manufacturing of the Climate Master geothermal equipment and ship our equipment worldwide. And the situation for you to go through is to hit the free registration tab once you've loaded the program. And when we hit the free registration tab and we open up GeoDesigner program, I want you to leave the program open. There's a couple of pieces of information we need to get and send back to the factory so we can get version registered. You'll pick up a computer code and a computer number. As we leave the program open, that will prevent those numbers from changing. If you do close the program, you'll need to start the process again. Every time you open it, it'll generate a new code number. When we hit the free activation code on here, we'll take an email will appear. I want you to copy the computer number and the computer code. We'll put that into an email, send it off, and normally within less than a minute, you'll get your authorization code so you can put in and register the program to make it a full working version of GeoDesigner. At this date, the program is available for regular IBM computers. We do not have a Macintosh version. That is something that's working forward to the future. Once we open the GeoDesigner program itself and we have it registered, you'll be able to go on here and look for updates. The current version is 3.202. In early 2012, there will be a new version of GeoDesigner available. As we have launched a new unit recently, you may have seen in the news, the TZ22 unit. In this program, we're going to open up and start with our job information. In this screen, you'll be able to put in the customer's information, location, contact phone number, information like that. Also at the bottom, we'll be able to put in dealer notes and any customer or client notes. And I normally put in some project information notes into here as to what type of system I'm going to compare to, depending on the options available at that job site. Some of this information will show up on a printout later that you can give to the consumer. I have a question for everybody to consider when they look at geothermal systems. What percentage of your customers would purchase a geothermal system from you if it provided some outstanding benefits? 25 to 50% energy savings, a 5 to 10 year longer life of the product. ASHRAE reports do show geothermal systems that have a life cycle of about 25 years. If this product offered a 30% federal tax credit, and if it reduced greenhouse gases or reduced the customer's carbon footprint. Many consumers nowadays are becoming aware of their energy use and what their carbon footprint is. If you were to offer geothermal on every sales call that you went on, would that attract 10%, 20%, 30%, 40, or 50% of your customers might really be interested in that geothermal system if you just offer them a price for it and start to talk about it. The next screen in GeoDesigner is our load information. We can either achieve this by hitting the tab at the top or at the bottom. And the first thing we're going to do in GeoDesigner in the load information tab is pick our weather city. GeoDesigner is going to give us the degree days, what our deep earth temperature is, our earth swing temperature, and how many days. It's important with geothermal designs that we know what our soil temperature is, and what we understand is that closer to the surface, that ground temperature is going to fluctuate throughout the seasons. As we're going into the fall time of the year currently, we'll see that it takes so many days for that ground temperature to change and how many degrees it'll change in that region. With horizontal loop designs, it's important to have that information into the program as we calculate the amount of pipe that's required into the system. The program will also show us what the average outside design conditions are for that region. Now, one thing I do want to point out to everybody, GeoDesigner does not do a manual J load calculation. There are many great programs out there that you can do a manual J load calculation with, whether you prefer a LEAP program or WriteSoft or however method you use for load calculation. However, it is very important that we take the time and do a manual J calculation to get the BTU requirement for heating and cooling in the region that we're working in that particular project. Once the manual J load calculation has been completed, we're going to input the heating BTU requirements, the cooling BTU requirements, and in the cooling section, we need to know not only the total load, but also what our sensible load is. We're going to put in our delta T that you used in manual J load calculation. The program needs to know what the temperature difference is from inside to outside that you use for your load calculation as we spread those BTUs through the entire window of the bin data that will apply for the region selected. We also need to know what our set point is on the thermostat for heating and cooling. And then in the cooling input, at what outdoor air temperature are we going to start the unit in the cooling mode? I'm one of those people that travel quite a bit, and with my house closed up and an auto changeover thermostat, I'll actually start running the unit when it's about 72 or 73 degrees outside. Realize this temperature is also the temperature that we're going to start an operating cost in the cooling mode. One of the other inputs on this screen will be our hot water input. One of the other big benefits with a geothermal heating and cooling system is being able to do a fair amount of the customer's domestic water heating. Normally this has a set point of about 125 or 130 degrees for our water heater tank. And then we need to tell the program how many people are going to use hot water in that building. The program will generate a load, a potable water load, so we can see how much energy we can save on doing their domestic water heating. In this load information screen, on the top right side, you'll see some slider adjustment bars. These are used if we need to fine-tune or tweak the program just a little bit for custom situations. I'll be honest, I don't normally adjust these at all. You can adjust them to the right or the left, increase or decrease. The only one that I do look a little bit is construction quality. If we're going out on a project on an older farmhouse, single pane windows, very little or maybe no insulation in outside walls, I may adjust that to the lower side, and we'll see the building balance point go up a little bit. I also do look at if I'm going out on planning a new construction job with the super insulated panels or insulated concrete form walls that has a very high construction quality, I might adjust that up 1 or 2 set points, and then my building balance point will go down slightly. The last input on this screen for us to select from is continuous fan operation. When we show an operating cost for heating, cooling, and water heating, we also have an option to show fan consumption, electrical consumption, and dollars operating cost. If we're going to compare to a PSE blower, maybe on an older existing system, and we're going to use our ECM fan motor, we all know there is some energy savings there, and it can be beneficial to show that to a consumer. Also, if we're going to recommend they run the blower continuous for air circulation, this would be the point we would select for that fan operating cost. So again, to review on this screen, we're going to pick the nearest weather city, put in our heating and cooling loads, our temperature differences, how many people are going to use domestic hot water in the building, and if we want to see that continuous fan operating cost or not. Once we've completed those inputs, we're going to hit the Done. At the bottom right of that screen, we'll hit Done, and we're going to come to the main screen in GeoDesigner. In this screen, if you need to go back and complete or change any of that project information, that's at the top left of this screen. We can put in our utility rates. We'll use these tabs on the left side to select what efficiency we want for our heating and cooling systems. And then we'll use these tabs on the right, lower right of this screen, to pick what type of systems we want to look at. So first let's go over here and let's look at utility rates. We're going to put in our electrical consumption, what our rate is per kilowatt for electricity, for natural gas, propane, LP, and if we are using oil, what we're paying per gallon on oil. Some utility companies will give us a discounted electric rate. If we're an all-electric home, we may get a discounted winter rate when they're actually looking to add load onto their power production facilities. I want to caution everybody when we go to put in utility rates that we actually take, and it's helpful if the consumer will share the utility bill with you, look at what we're actually paying on the utility bill and divide it by the consumption. How many kilowatt hours we use during that month, and divide it by the bill and get our true cost. My rates here in central Indiana that I have on my utility bill shows about 6.8 cents per kilowatt, but when I look at the actual delivered charge, including taxes and all the other fees associated, I'm at 7.5 cents a kilowatt. Same thing if I'm on natural gas, again, propane or oil. Once we put our utility rates in here, we can go to the top right and do a save file. We can save the utility rates for a certain market area or utility providers, and then when we come into this screen, we simply hit the Open Rate File, select the file for the market that we're working in, and it'll populate all those numbers. That'll help save you some time working with the program. Once we've put in the utility rates and that information, I usually go and do a complete file save as. I'm going to go back one screen here. We can do a file save as and save this as a template. It'll have our weather city, our utility rates, and when you come into the program, you can open your template and just adjust for the new project that you're working on. Okay, once we've completed our utility rates, we're going to select our system types. With the GeoDesigner program, we have the option of looking at two geothermal systems side by side. Maybe when we want to consider a package unit, all-electric system, and maybe we want to look at a dual fuel system with a gas backup. Or maybe we're going to use a water-to-water unit and do hydronic heating, and we want to compare that to a package or a split system. We can also pick an air source heat pump to compare to, or a gas furnace or boiler system. Once we select the type of systems that we want to do our comparison with, then we'll go into GeoDesigner and we'll actually pick what equipment by efficiencies. When we select GeoDesigner, we have a drop-down box that will allow us to select from any of the Climate Master geothermal equipment that's available. Single stage, two stage, water to air, water to water, split units, all the geothermal products are available on that download box. We're also going to pick what type of backup heating system we want, and is it going to be auxiliary heat or supplemental heat, or if we do a dual fuel system, we would override and shut down the geothermal once we would pick up that system. I do want to caution everybody here with GeoDesigner. The program does not do an auto selection of the unit. Depending on where your market area is and if it's a heating dominant load or a cooling dominant load, will drive your decision on what size unit is the best selection for the particular job that you're working on. If you're in a southern market like Texas, you're going to pick the unit off the cooling load and will probably be well oversized for the heating load of the building. In northern applications, we're going to pick the unit to do the majority of the heating load, but we don't want to grossly oversize in cooling that we might have dehumidification concerns. We'll look at how we select and make sure we have the correct size unit. Once we select the unit, then we're going to go in and we're going to pick what type of loop we have. In today's webinar, I don't have time to go through a complete design of overall loop systems. We'll include that into another presentation down the road. Realize we do have horizontal loop choices, vertical loop installations, and we could select a well water or groundwater open loop system. For today's seminar, I'm looking at using a vertical bore, 1 bore per ton. In the program, we're going to put in an average depth of the loop system. That average depth, again, drives what the temperature is around the piping will affect our heat transfer with the overall ground loop system. We're also going to put in, again, the average depth. I'm going to let the program auto size and tell me how much loop is required to maintain a minimum of 32 degrees in heating, 95 in cooling. 30 to 95, 32 to 95 are typical minimum and maximum temperatures that we use to design the ground loop system with. The unit will run outside of those parameters, but if we stay in that range, that'll give us a little extra safety factor if we get some extreme weather, like we saw this summer with some extreme high heat, and then sometimes in the winter some extremely long cold temperatures. Then we have to input the soil at our job location. Now, I know many times we won't know the exact soil at the site. I will typically recommend a damp silt and clay or a damp sand and gravel, and then when we go to do the actual installation, we need to verify at the job site what the soil is. Normally we'll know for a region if it's sand and gravel or silt and clay. It's confirming how much moisture is in the ground. That can be done with a simple hand test. Once we dig down into the ground, grab a handful of the soil, compact it in your hand. If a lot of water is gushing out around your fingers and everything, you might have a saturated soil. If we're getting some moisture on our hands, a little bit of mud, it's a damp soil. If we were to take that ball of soil that we put together and we set it down and it wants to fall back apart, we have a dry soil condition. That's just a quick method for you to determine moisture content. So again, we'll select the soil type for that location. And then our last input is what is our water heater selection. With the hot water generator desuperheater feature, we're typically going to do about 50% of their annual water heating. However, during the spring and the fall, during the mild conditions, and the geothermal unit doesn't run very often to heat or cool the building, we use a backup water heating method to make sure our customer still has hot water at all times. There are numerous selections on here for our water and for the water heating options. We could actually do a full-time water-to-water geothermal unit that would do on-demand domestic hot water heating for them. Once we've done our water heater selection, we're going to hit a run button on here, and what used to take hours of calculations is done within a matter of a few seconds here. And we'll get a printout or a screen, a new screen now inside GeoDesigner that's going to give us a tremendous amount of information coming out of here. One thing I do want to point out, if we're selecting the unit on the cooling load being our dominant load, in the bottom left portion of this screen, underneath where it says auxiliary heat, we would have a screen come up if the unit that we selected is undersized. It will tell us total cooling we can't meet or sensible cooling can't meet, and we would simply select the next larger unit to make sure that we're covering our cooling requirement. Also at the bottom right of this screen, there'll be a tab called bin analysis that we'll look at here in a couple of slides to confirm we haven't oversized the unit in cooling to cause a dehumidification concern. So let's look a little more deeply into this information and make sure we're getting the right size unit. The first thing I look at the top right is what percentage of the annual heating requirement is being covered by the geothermal unit. I like to see this in the mid-90% range. We want to do the majority of the heating requirement with the geothermal unit and minimum with the backup heating system. Again, the big reason your customers are going to buy geothermal systems from you is lower operating cost. In this example, we're doing 96% of the heating with the geothermal unit, 4% with our backup auxiliary heat system. Our cooling operating cost is also shown in this screen. In this example, I use the Indianapolis weather market area, which is my home territory. I'm probably going to run on low stage cooling through most all of that cooling season. If this is below 90% of the annual contribution with geothermal, I'd select the next bigger unit and look at our operating cost and are we getting to that mid-90 range. Now, folks, I know we're all kind of like Tim the tool time and bigger is always better, but do realize sometimes we can select a unit that goes so large to try and cover 100% of the heating that our operating cost actually goes up and our payback becomes longer and we've actually gone to too large of a unit. So you can try around with a few different size units till you get one that hits that mid-90s range for total annual contribution. In the bin analysis tab, we can look at information over here, and on the far left side of this screen shows our outdoor air temperatures, how many annual hours per year at that condition, and then towards the middle of the screen, our geo runtime in cooling as a percentage. What we'd like to see is at about 85-degree outdoor air temperature, we're at 50% runtime. That's enough run time for the machine to be able to pull moisture out of the air and do good dehumidification so we have a comfortable, cool home. We look between 82 and 87 bin hour, and we should hit about a 50% run time. If for some reason we're outside of that window, if we're still only at 30 or 40% run time by 87 bin hour, we might want to consider a smaller unit or consider using one of our dehumidification options. You do have an option to give the unit an input, and we can slow the blower down during the cooling mode on demand. Running a lower airflow through the air coil will pull more moisture out of the air. Or we may want to go to a ClimaDry option where we have a reheat coil behind the evaporator coil. Once we're done doing sensible cooling, you can actually run the unit in the dehumidification mode and pull the moisture level down into the building. So again, just look at your runtime in cooling, and we should be around 50% by 85-degree bin hour. Some of the other information that we get from GeoDesigner is our auxiliary heat options. In this case, GeoDesigner is recommending that we have 8 kW worth of auxiliary heat for additional heating during the extreme cold temperatures. It also recommends an optional 19 kW auxiliary electric heater. My choice would be that we put in the optional emergency heat just in case somebody cuts the loop in the wintertime or we have an extended period of time before we can repair a unit. Your customer can run the unit as an electric furnace. The other information that we're looking at here is our domestic water heating. In this case, the hot water generator is going to provide 57% of our annual heating requirement for a very low cost. The remainder of the domestic water heating is being accomplished with electric water heater tank. Again, there's a huge benefit with that water heating being done with the geothermal unit. I didn't select the continuous fan option, or we would see an operating cost for this at that point. And here's our total operating cost for the geothermal system, just slightly over $1,000. So once we're confident with our selection on the geothermal unit, we move to an option if we want to do a water-to-water unit. We can make hot water or chilled water with the geothermal unit. When we select a water-to-water product, we put what our load temperature will be, size of the unit, and then we need to pick how are we going to apply that unit within the system. Is it going to be a standalone unit with hydronic fan coil cooling? This is what I see in many applications. We'll do radiant floor heating for the building and do hydronic chilled water fan coil systems. We could also do this with full-time hot water and do all their domestic water heating with the geothermal unit. And then what I really prefer is to do the tandem with a ducted geothermal heat pump unit. The water-to-water unit provides hot water for radiant floor heating, hydronic fan coils, or whatever distribution we have for hot water. We can use a packaged geothermal unit to do our additional backup heating, our air circulation, our humidification, our air filtration. We're going to need a forced air duct system into the building anyways to do air conditioning, so we could use a full unit and provide the advantage of having 2 systems to be able to take care of heating and cooling needs. And then our last option would be in tandem with full-time hot water, that we could do all their domestic hot water heating needs for the home also. And another item to show you in GeoDesigner. As I see a lot of our installations go into custom homes that have multiple units in the building, rather than doing separate runs with GeoDesigner, we can put in the total building load, select what series of product we want to use in the building, and then enter the total tons that we're going to install. And we can get an operating cost comparison of various systems for the entire building. Now, I do want to tell everybody that GeoDesigner is good for about 25 tons of total capacity. If you're doing a project larger than 25 tons, it's going to start to have a load profile that's more like a commercial building and maybe not act quite like a residential building and the load profile we typically see there. So we might run that in a different program if you get into a bigger project. Okay, once we have our geothermal unit selected, we can go and select an air source heat pump system for one of our comparison units. With the air source heat pumps, we're going to select the unit by the efficiency, EER, or SEER rating of the unit. Realize we also have options that go back to an 8, 10, 12 SEER unit if you're looking at an existing home and we're trying to convert them to a geothermal system. So we'll pick off the SEER rating, and then we're going to put in what capacity of the unit. On our example with GeoDesigner for the Climate Master geothermal unit, I picked our Tranquility TTV 049, a 4-ton unit. So I'm going to put in a 48,000 capacity air source heat pump and realize we have an option in here if we want to do a cutoff temperature. If you actually do shut off an air source heat pump at an outdoor air temperature, you can input that, or you can run this down to -20 or -30 to have that air source heat pump run throughout the winter. Next, we're going to pick coil combinations and coil conditions. Typically, I'm going to pick a average coil for an outdoor air conditioner coil. Hopefully they have you out there once or twice a year to clean the coil. We know it doesn't stay clean for very long. And then we're going to pick what type of backup heating system we want. There's a drop-down menu in here, the same thing that we'd use with the geothermal selection. Boilers, natural gas, LP, oil, electric heat selections. This could be a natural gas furnace or an LP furnace. For our example, I'm going to stay with just all electric to start with, but if you do want to do a dual fuel application, you can pick up a gas furnace for your backup heating system. And then we're going to also select our water heating option for the air source application. Once we hit that run button again, we'll get our operating cost comparison, and this will be for the air source heat pump operating cost, heating, cooling, and domestic water heating. Our third option that we picked was a gas furnace air conditioner choice. I have that same drop-down menu that we had for the backup heating system. This would be our main heating system for the gas AC choice. I'm going to pick off of the air conditioner, off of the SEER rating. With an AC unit, I go up to an option of a 21 SEER, and again we have the older 8, 10, 12 SEER options. We'll have the drop-down menu again for the water heating selection and our coil conditions. We need to pick what type of water heater we're going to do. I actually did this again with a natural gas instead of a propane water heater. My choice was a 93% condensing gas furnace with 15 SEER air conditioner, like we did a 15 SEER air source heat pump. And here's our operating costs for our gas AC system. Again, heating cost, cooling cost, and our domestic water heating cost. In all options, I did not select that continuous fan. We're over $2,000 in operating costs for the gas furnace. Another question for all the attendees today. Think about how large of an energy savings is needed to motivate your customers to purchase geothermal system from you. We all know that the economy is pretty rough right now. Everybody's budget's pretty tight. Everybody's looking to where they can save some money. And definitely with geothermal, they can save some big dollars on their total monthly budget to live in their home. Would it take $25 in energy savings to motivate a customer to buy geothermal from you? $50 a month? $75 a month? Could you achieve $100 a month in energy savings? I think we're somewhere in that $50 to $75 range. If I could save $75 a month on my energy bill, that's about $900 a year. That's close to $1,000 a year. And over the 25-year life cycle of a geothermal system, that's $25,000. That's some pretty big savings to put into somebody's pocket. So once we've done our selections, we can go to the GeoDesigner printouts. There's a Reports tab in the main screen of GeoDesigner on the left side where we can pick up reports that we want to print out and show to the customer. On the GeoDesigner printout, to start with, we're going to show our customer information. You can input your dealer information into here, your contact information, address, all that important information. You know, those notes that we did on some of the inputs early on. We're going to show the customer what their heating load is, what their cooling load is, what our set points were, and then we actually show them the annual heating and cooling requirements in BTUs plus their domestic water heating requirement. In this case, with 4 people, it's 70 gallons per day. Then we're going to show them a side-by-side comparison of the gas furnace, the air source heat pump, and the geothermal unit, what our heating costs are, our cooling costs are, our domestic water heating cost, and then a total cost. On the far right side of the screen, we're going to break that down into 12 equal monthly payments just like they were on a budget plan, so we could do a side-by-side monthly comparison of what our costs are going to be for the various systems. In this example, using my utility rates, Indianapolis market area, I have a $97 a month savings versus a gas furnace and air conditioner. And this is a condensing gas furnace and a 15-SEER air conditioner. That's almost $100 a month in energy savings for your customer. Comparing to the 15-SEER air source heat pump, I'm at $73 a month savings each and every month. In the screen, we also show them what the energy costs are per kilowatt, natural gas, propane, and fuel oil. So there's no smoke and mirrors behind the program. This is valid numbers. These are the energy costs that we used. I think that's a pretty significant savings that we can show your consumers. Also in GeoDesigner, we can do a printout of a bar graph. Some customers do good looking at hard numbers. Some other customers will see it better if we put it onto a graph. Now realize in the order that we selected our heating and cooling units is the order that we're going to show up on this bar graph. I picked that gas furnace first because it shows up as red on the bar graph, and that usually shows caution to a customer, and typically that's the highest operating cost a gas furnace AC application, depending on what your local utility rates are. The geothermal system was selected last, so it's shown up in the blue on our screen. You can change the order of those in GeoDesigner in that main screen if you desire. Okay, the operating cost was one of the very important things out of GeoDesigner. The other thing that's going to be important is how much loop is required for this project. Depending on our soil conditions, our building loads, the unit selected, and the local weather data will determine how much loop is required with the system. I can't stress to everybody the importance that we get the proper amount of pipe put in the ground with the system so the whole system works properly and you have a happy consumer that will go tell other customers how great your installation was. In this screen, I chose damp sand and gravel for my soil conditions with a vertical loop, and the program's telling me that I need 805 feet of total vertical bore. With geothermal designs in residential, with 3/4 inch polyethylene pipe, we typically do 1 circuit per ton for the installation of the ground loop system. So in this example today, with a 4-ton unit, I would take that total bore depth of 805 feet, divide it by 4, and I would need 4 boreholes, minimum of 10-foot spacing between boreholes, at about 200-foot depth per borehole. We'll tie that to a common header, bring our piping back into the system to our central pump. If we were in a region where we were going to be drilling through rock, sometimes I hear from contractors that, boy, it's a lot harder to drill through rock. Well, instead of using a mud rotary rig to drill the borehole, we would use an air hammer rig to do the drilling, and it can be accomplished. Do realize there's some advantages if we're going through rock. It's better for heat transfer, it has a better conductivity value, and our bore depth goes down. In this screen we look at with average rock, our bore depth went down to a total of 570 feet. I would again divide by 4 to get my bore length per hole, and I'd need 143 feet per borehole, 4 holes. So we could do about 150-foot boreholes and actually have less requirement for the depth of the total bores, better heat transfer with the rock than we had with the sand and gravel soil. If we have land space available and we can use a horizontal loop system, a 4-pipe loop system is very common throughout the United States. Now do realize as we look at this as a 4-pipe design, it's actually 2 circuits. We put the 2 circuits in the bottom of the trench, run them out to the end, bring them back on the return at 2 feet higher than where we went out. We staple them up along the side, and we do 1 backfill of the soil. When we do backfill, we want to make sure we don't have sharp rocks or objects that might damage the pipe down the road. Also, when we talk about average depth, one of the inputs we did in the loop design portion, I need to know the average depth of those two pipes. Typically we go at 5 foot with the bottom, 3 feet with the return pipe, so my average depth would be 4. However, I do like to stay below the frost line in the local region. As I go to some of the northern markets, we may be at an 8 foot or 10 foot depth. I do just want to caution you, if we're going to deeper than 5 feet, we want to shore up the sides of the trench or cut the tops in at an angle that if some of the soil were to cave into the trench, we don't have any concerns there. So with staying with the damp sand and gravel for my soil conditions and an average depth of 4 feet, GeoDesigner tells me that I need a total trench length of 710 feet. However, I want to stay with my 1 circuit per ton, so I need 4 circuits out there in the ground. In this case, I would take the total trench length, divide it in 2, and I would have 2 trenches with 2 tons or 2 circuits in each trench, 10 feet spacing between the trenches, and I would have 2 trenches at 355 feet each. Okay, so once we know how much our loop is, we can go to our loop contractor and get their price to do the loop part if you don't do the loop installation yourself. Put that with the mechanical installation, and then we can do an evaluation for the consumer. Now, one of the objections we hear many times from customers when we want to sell them a geothermal system is, geothermal just costs too much. And that's an objection that we need to be able to explain to the consumer, that we should really look at what's the total cost for their system. Not just the purchase price, but what's the operating cost also. We need to look at a total monthly payment. Let's think about the last time you went to buy an automobile. Did you consider the miles per gallon of that automobile as part of your purchase? Certainly part of your monthly operating cost for that machine is your fuel cost. So I'm going to look at another program. Sorry, first let's talk about this screen. How much of a reduction in total monthly payments is required to get your customers to purchase geothermal from you? Would $10 a month total monthly payment reduction be enough to motivate a customer to want to buy geothermal? It's positive cash flow. It would be beneficial, but I think most customers want to see $25 or greater savings in their total monthly bill to be motivated to purchase geothermal from you. So to be able to generate those numbers for your customers, we're going to look at the sales proposal program. This is another free software program for you from Climate Master that you can download from that CMDealer.net website, same place we downloaded GeoDesigner. In sales proposal, I've input some cost in here for the total install cost of the system. I'm looking at this as if it was a new house and we were going to do the duct work, the loop system, and the equipment as a total installed for a new house. Almost $25,000 for the geothermal, over $9,000 for the comparison systems. And we're going to look at total monthly payment for the customer. In this example, I've done it as a 30-year loan, 6% interest rate, and inflation rates for the fuels of 3% for electricity, 5% for natural gas, again, as a new house total system. In this case, with those install cost and operating cost, yes, geothermal does cost more to own the system, but the operating cost is so much lower that my total monthly payment goes down. In this example, I'm going to save $41 a month versus an air source heat pump, or $67 a month versus a gas furnace AC system. By giving this information to your customer, you can simply ask, what monthly payment would you like to have? I can put in any of these systems, but it's your choice. Which total monthly payment do you want? And I've seen several of my contractors that have started to actually ask people, do you want to pay the extra money for that air source heat pump or gas furnace? And then let them make the choice. As we've seen today, there are huge advantages for a geothermal system when we compare it to other heating and cooling system options. I want to thank you for your time today. Hopefully you picked up several things that can help you be successful with geothermal systems. If you do have additional questions, you can send me an email, and I'll address it, or I'll share your information with one of my other district region managers, and we'll follow up with you to give you support to help you be successful with Climate Master geothermal heating and cooling systems. At this time, I'd like to pass the presentation back to Mike Murphy.
Hey, Richard, thanks very much. And as Richard said, you can send some questions his way, but we've got a lot of questions already stacked up in the system here, Richard, so we're going to hit a few of them. But, and just remind everybody, now's a good time if you do have some questions about Richard and his presentation on GeoDesign. Now's a great time to go in there, type in your questions, and we'll cover as many as we can get to. So, hey, with Richard, I thought I'd just start with the first one that's in there. How accurate are the operating cost estimates that come in from the GeoDesigner format?
Mike, that is a good question. I do get that occasionally. I've actually taken some time and compared operating cost in a couple other software programs. Many of us are familiar with RightSoft and Elite, and when we've compared to those programs, we're typically within 2 or 3% of what they show for operating costs. So I do feel GeoDesigner is very accurate.
Okay. Hey, well, there's a variety of questions that come here, and some of them are more about loop design and things of that nature. But how about if I go right into the ones just about the software first, and if we have time, we'll hit some of those others too. This question comes in from a gentleman named Glenn Clark at Renew Mechanical, and wants to know if the program takes into account the flow center pump operating costs. Richard?
Well, that's an interesting question, Mike. Does the program consider the cost in energy for the pumping? Per AHRI, as we rate and certify the equipment, we do have to include a pumping penalty for the watts consumed by the geothermal system. So yes, when we look at that operating cost, it does include a value in there for the watts consumed in moving the fluid through the ground loop in the machine. Yes.
Okay, great. Another similar question. Does the system take into consideration the grouting when doing a horizontal loop? That question came from a guy named Brad Papajoy, who must know you. He's out in Moline.
Thanks for the question, Brad. There are some conductivity factors that are figured into this. Everyone, as we're listening here, there is some talk within the industry when we do a horizontal boring system, do we do grout in there? My personal recommendation is that we do. We all need to understand that we certainly need to have contact from the pipe to the soil around it or through grout and to the soil around it to get the proper heat transfer of the system. Now, certainly in a vertical application, we're always going to want to grout the borehole all the way from the bottom to the top of that bore. In horizontal systems, there is some values that are considered into there for the heat transfer. And I won't say it's directly got a value we can input for grout, but yes, it does take into consider heat transfer between that pipe and over to the soil and what material might be directly around the pipe.
Okay. Let's see, another question coming again from Glenn Clark out of Renew Mechanical. Wanted to know if there's going to be any changes with the new release of the software that's coming out in 2012.
That is a good question. We do listen to the field, and there will be a couple of changes, my understanding at this point, a couple of changes to GeoDesigner. One will be some other options on the comparative system, some different efficiencies. There's some other new technologies that are coming out in systems at a little higher efficiency, so we'll give some other options there. On the geothermal side, there will become an option for our TZ22, what we're calling a Tranquility 22, that has a two-stage compressor and a built-in variable speed loop pump. One of the things that we see in commercial buildings is that we go to a variable speed pump so we can reduce the watts on the pumping side of the system, which affects the overall efficiency of our total installation. So yes, as we come out in 2012 with GeoDesigner, there should be a couple of changes, the TZ22 and some other options on the comparative systems.
Okay. Some more questions. When showing the customer the project price, should I deduct the potential federal tax credit amount, or is that already done for me in the software?
That is a valid question. We do want to look at the consumer and not directly ask questions, but get an idea that they will qualify for the federal tax credit, which virtually almost all customers do. Nonprofit businesses don't, but anybody that is a regular homeowner should qualify for that tax credit. In the sales proposal program, you're going to have an option, do you want to show it with the tax credit or not? And I'm going to say yes. Almost every time I would show it with the tax credit engaged and involved in there. It'll actually help reduce our total install cost. If the customer doesn't use the tax credit in the following year, they'll have the remainder for the following years till they finally use all that tax credit. So eventually, as they go down the road, they will be able to take advantage of the full tax credit that we put in there for them. So in that case, I'm going to say yes, we should.
Okay. Well, let's see. This question comes from Bernard Voigt and Richard. Richard, I don't know if you remember him. And for the audience, Richard and I used to work together years ago. But Bernard says, Mike, did not realize you were so ugly. Richard, I'm pretty sure he was confusing me and you on that question, wouldn't you think? Let's see.
Yes.
He's with Geosystems. I think he's out of Virginia. But let's see. Another question, a real question here. Yeah, when offering a geothermal quote, should I include a good, better, and best product option for people?
That's a fantastic question there, Mike. You know, I know a lot of contractors, when we go out, we give them a good, better, best option. What I like to see us do is 3 geothermal options. Of good would be a R410A unit with a single-stage compressor. Our better option would be the 2-stage Tranquility 27 option. And then actually the best option would be a TTV with a standalone water-to-water unit to do all their domestic water heating, snow melt, pool heating, anything else we might want to do. What we do see with consumers is when they get that good, better, best option, many times they'll want the best option, but that might be slightly out of the budget of where they want to go to, so they'll step down to the better option, and that would be the Tranquility 22 or 27 at this point. So I think if we give them those 3 options, it's going to help more people move up and go to the Tranquility 27 choice.
Okay. Hey, Richard, along those lines, maybe if I could just piggyback on that question. With the GeoDesigner software, will it automatically spit out those 3 options if you ask the software to do so, or do you have to actually go back in and ask for 3 separate comparisons?
By how in that main screen in GeoDesigner on the far right, when we pick the different types of heating and cooling systems that we want to use, that will do that into the printouts, but we do have to go in and actually select the efficiencies of the units that we want to compare to. As we're all aware, we're not too many years away from that 80% gas furnace being eliminated in the northern climate, and we'll go to a higher SEER rating in the southern markets. So we do need to go, after we pick gas furnace, air source heat pump for the comparisons, actually pick the efficiencies of the systems that we're going to compare to. So we give the customer more valid output and see operating costs that are going to be more what's realistic.
Okay. Thanks. And Barry Haney at CEC Services asks, does the GeoDesigner software plan to include 1-inch U-bends in the program for vertical loops?
Valid question, yes. As we see in many areas, we do go to 1-inch pipe in vertical installations. We do have an option to select a 1 or 1.25-inch pipe on the vertical systems. We all understand as we go through designs, we just need to make sure that we keep the flow rate up to the proper flow rate required to get our Reynolds number, which refers to how turbulent is the flow of the fluid going through the piping system. So, yes, you can go to bigger pipe system. Just ensure that when you go through your design and your pump selection that you have enough velocity and flow of the fluid to keep a high Reynolds number to get proper heat transfer. So, yes, you can do that.
Okay. Hey, Bernard with Geosystems came back with a question I like even better this time, Richard. He wants to know if the program will accept differentials for thermally enhanced grout.
Wow, this gentleman's very knowledgeable on his geothermal loop design, Mike. I'm impressed.
Yeah, I think he is.
He certainly is. In the residential GeoDesigner program, what we use are the ICSPA, International Ground Source Heat Pump Association standards. 10-foot spacing between boreholes, and a standard grout. If we do not get the option to put in thermally enhanced grouts or to put in an actual thermal conductivity in the soil. There is a commercial program that we have available and we can use that we could do those types of designs if we want to get that increment or that involved and that in-depth in the geothermal design. So In the residential GeoDesigner program, no, we don't go that far with the design inputs, but we could help somebody that wanted to do that with a different program, a commercial design program that we can also do some residential with.
Oh, okay. So, for instance, a geo contractor would get in touch with his local rep to help him if he needed to go into that level of detail, I guess?
Yes, the local distributor, and we can gather some information for him. We can help run it through a program and then feed him back the output from the program.
Okay. Hey, Mr., or I can't tell here from the initials, but someone named Dillman out of Thermal Supply Incorporated has a question that says, does the system comparison have an option for comparing ductless heat pumps? Thanks. So like a mini-split type approach.
And good to hear the question from the thermal supply folks out there. At this point, we don't have an option for a mini-split, a ductless split option. Not sure that will be one of the new options in 2012. I do know as we talk with contractors and distributors, we are seeing that product movement increase a little bit out there in the industry. I think it's just trying to help reduce installed cost. There'd be a little savings on the fan watts, but I would probably go ahead and do a comparison with a regular air source heat pump or air conditioner at the same SEER rating, and that should be pretty close and valid on our operating cost numbers. But no, at this point, no, we don't have an option in there for a mini split duct system.
Okay. Hey, Richard, I think we've got time now to get a few other questions, a little variety here outside of just the software questions, if you don't mind. This one comes from a company called All Climate Incorporated, and interesting question. He said, hey, look, there's a 4-pipe, there's a 6-pipe. Well, why not an 8-pipe or a 10-pipe system? And if there were any other variations, and I'm asking this part of the question, I guess part B, could they input that in GeoDesigner if there were any alternative designs?
That's a very interesting question, and as I've done loop design for quite a few years, I do go to some markets that do more than a 4-pipe design. In the program, we do have the standard IXPA option of a 6-pipe design, which puts 3 circuits into one trench, or typically in residential, that's 3 tons in a trench. When we go to the job site and we do an evaluation, we have to determine how much land space is available and what loop can we fit onto that site for the lowest upfront installed cost. They're all going to perform pretty typically when we look at operating costs, but what will fit on the job site at the lower cost. So here in central Indiana, we do some of that 6-pipe design, but what we do understand is the more pipes that we put into a trench, we get more thermal interference, and therefore every circuit length goes longer and longer. The more set of pipes we would add into a trench, maybe an 8-pipe design, then we get more thermal interference, longer trench length, more pipe requirement. There is another program that I use where we can put in the thermal conductivity that I can put in more trenches or more circuits in each trench, but typically I have to go from a 2-foot wide backhoe trench to a 3-foot wide trench to be able to get in more pipes. So in the residential GeoDesigner program, no, we do not have that option. But if somebody's getting into a specialized design like that, again, we can work with the local distributor, gather some information from them, and assist them through a loop design in some type of process like that. But I must be honest, an 8-pipe or 4-circuit design in one trench is going to have a lot of thermal interference, and we just have to be cautious if we do one of those type of designs. Not that it can't be done, but a few extra steps we would want to take and go outside a GeoDesigner program.
Gotcha. Hey, Richard, this is probably maybe the most important question. I saved it to the last. Where do I go to get the GeoDesigner program and the sales program? Asked Dave Mitchell out of Link Heating.
Well, Dave, thanks for the question. We're really glad you want to get the program. I know it's going to help you be more successful with geothermal system sales. Our dealer website is cmdealernet.com. cmdealernet.com. And on the top header across there, you'll see one that says Sales Tools. Click on that link for Sales Tools, and then on the left side of the new screen that appears, you can download all of our software programs that are available. These are given to the contractor at no charge. We want to help you be successful with geothermal. And then You can go to your local distributor. Our district region managers backs up and supports all the different distributors. Generally, they'll have a geothermal expert in-house or a geothermal product manager that can help with that software programs. If they need assistance, they'll come to our district region manager. So cmdealernet.com, guys. You can get all your software for free at that site.
Well, hey, that looks like a good spot to end on, and we're right on time. So with that, Richard Hiles with Climate Master, we want to thank you very much for an excellent presentation today, and thank Climate Master as the sponsor.